Good day, ladies and gentlemen. Welcome to Bright Engineering. Today, we are going to look at complex numbers, and under this topic, we are going to find the modulus and arguments of complex numbers. So, already we've learned that when we are given complex numbers, we have the real part of the complex number, that's the value without the I, and the imaginary part of the complex number, that's the value with the I. So, with the modulus and the arguments, we just want to find a common value for the complex number and then the angle between those two values. So similarly, when we are looking at trig functions, we know that we have this to be our hypotenuse, this to be our opposite, and this to be our adjacent. And this is the angle theta between the hypotenuse and the adjacent. So whenever we want to find this hypotenuse, we know that our hypotenuse squared is equal to this opposite squared plus the adjacent squared. And we can now find this hypotenuse as the roots of our opposite squared plus adjacent squared. And that same way, if you want to find this theta, now we are going to use the opposite and then the adjacent. And in order to use this opposite and the adjacent, we have to introduce the trig function tan theta. So here we can say tan theta is equal to the opposite over the adjacent. And to find theta, our theta now becomes tan inverse of our opposite and adjacent. So in short, this hypotenuse here becomes our modulus and this theta becomes our argument. So let's look at some of the examples that we have here. So for the first question, z is equal to minus 1 plus 2i. Now, modulus is represented by r. So instead of the h, we represent the modulus by r. So here, you can see that our r is equal to root of the x squared plus y squared. Don't forget your I. So interestingly, whenever we are solving questions like this, always the real part represents the x coefficient or the x variable, and the imaginary part is that of the y. So here we can say that our modulus r is equal to root of this minus 1 squared plus 2 squared. Now you would ask why we didn't bring the I here. So this I is just showing us that this is the imaginary part. But then when we are finding the modulus of it, we don't bring the I or we don't add I to it. So here we can see that our R is equal to 1 because minus 1 squared is 1 and 2 squared is 4. So R is equal to root of 5. Now we have to find our arguments. Like we did with the first one, we know that our argument, which is the theta, can be found using the tan trig function. So tan theta is equal to the opposite over the adjacent. So clearly, if you look at this diagram, we can see that the opposite side is the one that represents the y-axis, and then the adjacent represents the x-axis. So when we have opposite over adjacent, it means that we have the y component over the x component. And here we said that the y component is always the one with the imaginary part, and then the x component is the real part. So our tan theta is going to give us 2 divided by minus 1. And we can find theta to be our tan inverse of 2 over minus 1. Now theta is going to give us minus 1.107. And we are done with the first one. So now, second question. Z is equal to root of 3 plus I. Now we are finding our modulus. Our R is equal to root of this squared, which is root 3 squared, plus I is the same as I, 1I, so we have 1 squared. So here we are getting root of this square, will take away this root sign, so we are getting 3 plus 1, and we have root of 4, which is the same as 2. So our R is equal to 2, and now our theta is equal to tan inverse of this divided by this, that's the y component over the x component, and our tan is equal to theta is now equal to pi on 6. So it is very important that whenever you are finding for your arguments, you change your calculator to rad so that you get your answer in terms of rad. So here this answer is in terms of rad. If you change it to degrees, you're going to get a different value, and here too is in terms of rad, and when you change it to degrees, you're going to get a different value. Thank you very much, and if this section has been very impactful, please don't forget to share, subscribe, like and comment. Thank you.